median. So the measure of center we're going to work on at first here is median. So median, like I told you yesterday, is the number in the middle. If it's an odd amount of numbers like this, we have 7 total numbers here, then there's going to be 1 in the middle. So in this case, the 1 number in the middle is 8. So my median is 8. Now, since 8 is my median, you cannot include it on the left side and you cannot include it on the right side. So when I say what's the middle of the left side, of the lower side, you're looking at these 3 numbers only. What's the middle of the lower side? 7. So the lower quartile is 7. Now the middle of the right side is 14. So my upper quartile is 14. Now those 3 values right there are what's contained in the box. We call that the quartiles. So let's make our box already with those 3 numbers. Now let's number this number line here from the smallest number all the way to the biggest number. So how do you know how many ticks to make on this line? By finding the range. 14 minus 2 is 12. That tells me I need 12 sticks here, because it needs to go from 2 all the way to 14. So we have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now we know that all of the information we have is going to fit on our number line. So let's make our 3 first lines, which make up the box. 8 is the median, 7 is the lower quartile, and 14 is the upper quartile. Once you have these 3 lines, connect them and make your box. That right there contains 50% of the information. 50% is in that box. Now, the minimum and maximum are the only things missing here. The minimum is the smallest number, which is 2. So you put a little line on 2 and connect it to your box. We're done with this left side. Now the right side, the maximum would be 14. But in this case, it's already touching 14. So I don't have to extend the whisker to touch 14. It's already on 14. So we're done. This is our box and whisker plot. All right, we did this yesterday. Now we get to the new stuff. So before we get to the new stuff, I'm going to recite the definitions for the first ones that we learned yesterday. So first one we'll talk about is mean. Mean is an average. So all you do is add each value, then divide by the amount of total values you have. You guys all should know how to do that. That's a regular one that we start off with in 6th grade. So add them all up, divide by how many numbers you have. The mode is the value that repeats the most. Now, what most people don't know about the mode is that you could have 2 different answers. You could have 3 different answers. If the winner of the repeated the most is a tie, then both numbers are the answer. So if there's 5 3s and 5 5s, then 3 and 5 are the mode. So there could be more than one answer for mode. The next definition we talked about was median. Median is just a number in the middle. But how do you know what's in the middle unless you order it from least to greatest first? Next is the range. Range is just how spread the information is. So from where to where does my information lie? It was from 2 to 14 on my example. That's why you subtract those numbers to find the range, the distance between your smallest and biggest number. And then the last one, which is what we're going to focus on today, is outlier. Outlier is just like the word says, a point that lies outside of the rest, or a point that's very different from the rest, an extreme value. So the examples of those extreme values are here, right? Sometimes your extreme value is a small number. So like all your numbers are 80, 82, 85, and you have 3. That number is very different from the rest. That's an outlier. So sometimes it's a small outlier, sometimes it's a big outlier. What if all your numbers are 10, 11, 12, 300? 300 is the one that's very different from the rest. That would be an outlier. So now we can move over. Actually, let's talk about quartiles before we move over. The quartiles, when ordered from least to greatest, The middle of the left side is the lower quartile, and the middle of the right side is the upper quartile. The median is the second quartile, quartile 2. And then the interquartile range is similar to the regular range, but instead of subtracting the biggest number from the smallest number, you're just subtracting the upper quartile minus the lower quartile. So now we get to the new lesson for today. The first thing you need to understand is when to use these measures of center. You can use all three on any problem. Which one is the best one to use? Now, this information is easy to remember, so pay attention. For the mean, average, the best measure, this is the best measure to use when there's no extreme values. So the best measure to use when there's no extreme values is mean. The best measure to use when there is extreme values is median. And the best measure to use when there's a lot of numbers repeated is mode. Now, this is easy to understand if you think about it logically, right? When you calculate the mean, do you include that weird or extreme number? Yes, because how you find the mean is by adding up all the numbers and dividing by how much you have. So if it's included in the solving process, then it will affect the mean. The key is to use things that are not being affected so much because it's more fair. The median is the number in the middle. If you have a little number in the front or a big number in the back, that doesn't change that the middle number is still the middle number. So the median is the best one to use when you have extreme values because of that. It's not affected by a bigger or smaller value because you're just looking at the number in the middle. And then mode is self-explanatory. It's same as the definition. If numbers repeat a lot, then use the mode. Now, the next page, the effects of outliers. Now, in this page specifically, pay attention. So here on this page, we're looking for specifically how an outlier affects the mean and the median compared to each other. So what does that mean? They just want to know that you can verify which one's greater or which one's smaller than the other. So this is what you need to know for any standardized exam. Need to know when the mean is greater than or less than the median. So I have an easy trick to teach you that. Wherever this bottom statement is what explains the trick. So the bottom statement says the mean goes where the outlier is. So that tells you if there's a small outlier, which means there's a small number that's very different from the rest, then that word mean is going to go to that side. So that would just mean that mean is less than the median when there's a small outlier. So now in the second example, it's an example with a big outlier, a big number that's very different from the rest. Again, the word mean goes with that outlier. So that means that the word mean is on the right side, median is on the left. So how we read this is the median is less than the mean. So here in green and blue, I kind of summarized that for you. When there's a small outlier, mean is less than the median. When there's a large outlier, the median is less than the mean. Make sure you copy that down. This is very important. All right, let's move on to the next page. On this next page, I just gave you a little list as to what exactly is and is not affected by an outlier. The reasoning we talked about before, if it's not being used to calculate it, then it's not affecting it. So in this case, the mean and the standard deviation are both affected by the outlier. Why? Because when you calculate the mean, you need to include the outlier, as opposed to the median, where you're just looking for the number in the middle. The small or big number is not even included in the process. Also, standard deviation deals with mean. So whatever answer you have for mean, you copy the answer for standard deviation. So if the question was, which are affected by outliers, then you have to say mean and standard deviation. Now, before I show you what's not affected, let me explain to you what standard deviation means. To find the standard deviation is 2 steps. First, oh, 3 steps actually. First, you find the mean of the data. So you add them all up and divide by how many you have. Once you do that, you subtract each value from the mean. That's just for you to see how far each point is from the average, from the mean. And then all those small little numbers that you have, when you subtract, you're going to find the mean of those numbers, and that is your standard deviation. Now, I'm not going to make you calculate that in this class, but there is a question that you're going to have to be able to answer on it, and you'll see it on the next page or the following. Now, here in purple, these are the ones that are not affected by the outliers. The median is not affected by the outliers. The mode is not affected by the outliers. And the interquartile range is not affected by the outliers. Because an outlier, by definition, will be the biggest and smallest point. To find the interquartile range, you're only subtracting the upper quartile minus the lower quartile. You're not including those values on the ends. Now, this is very important. Please pay attention. Now, first we talked about what effects the outlier has on the measures of center. Now we're going to talk about what effects happen when you remove an outlier. So when you take away the outlier altogether. So I'm going to do the left one first. On the left example, the smallest number, or the outlier, is 2. So if I eliminate the number 2, how will the mean, median mean, mode, range, and standard deviation, how would they change? So it's simple. It's common sense if you think about it. You're adding up all the numbers. Well, let's start with median. Median is a number in the middle. With the 2 in there, the number in the middle was 23. But now if I take out the 2, the number in the middle is now going to be 23 and 25. So 23 was the original median. 24 is the new median. Did it increase or decrease? It increased. So we know that the median increases when you take out a low outlier. Now, to find the mean, you add up all the numbers and divide by how many you have. If you take away a little 2, and now you add the numbers and divide what you have, the value is going to be bigger. No, it's going to be smaller because you're dividing by a smaller amount of numbers. So in this case, the mean decreases. These things you can memorize, but the second one's going to be backwards, so make sure you pay attention to both. Now, the mode is not affected. Now, I'm going to go ahead and click not affected for mode on the right side because in any situation, an outlier does not affect the mode. Now, let's go back to the last 2 here. Range is the biggest number minus the smallest. 28 minus 2 would be 26. But if I remove that 2 and do 28 minus 21, now I have 7. That value decreased. So the range decreases when you have a low outlier. And now standard deviation, you don't even have to think about it because you match the answer you have for mean. Mean decreases when there's a small outlier, which means also the standard deviation decreases. Now let's look at the second example. I'll put these check marks in green so you can see the difference. Now in this example, the outlier is a big outlier versus a small outlier. So when there's a big outlier, the number in the middle at the beginning is this 8. But if I remove this outlier, now the number in the middle is 7 and 8, which would be 7.5. Did the median increase or decrease? The median went from 8 to 7.5, so the median decreased. So small outliers removed, increased the median. Big outliers removed, decreased the median. Now the mean is going to be similar. If when you remove a small outlier, the mean decreases, when you remove a big outlier, the mean increases. Now again, mode is never affected, so you can put not affected on both boxes there. Now let's look at the range, because you don't want to just answer the opposite of what you have here. Some situations, like mode, are the same answer. So it's always good to test it out like I'm doing up top with values. So over here on range, if we start off with the range without removing the outlier, it'd be 40 minus 2, which is 38. Now if I remove this 40, the outlier, and now I find the range is 10 minus 2, which is 8. As you can see clearly, that range decreased. So that tells you when there's a small outlier or a big outlier, it doesn't matter. In both cases, the range is going to get smaller. The range is going to decrease because the information is not as spread anymore because they took out either the very big number or the very small number. And again, standard deviation, you're matching your answer for mean. So if the mean increases, the standard deviation also increases. This is important. Please make sure you copy it, take a picture. Make sure you have this information somewhere so you can review it. Like I said, you can just memorize these statements that I have with the checkbox, with the checkboxes. All right, so now we get to the final part. This should be the final page. Let's review. Okay, analyzing. So this is the final part in terms of questions. The others are just going to be analyzing. Of course. This one? Let me know when you completed copying and then I'll move on. All right, so on this next part, this is a percentage style questions. So all you need to remember, and this is very easy to remember, is that between every space, it's 25% of the data. Between every space or every value that you calculated when you created your box and whisker plot. So look at sample question number 1. What percentage of the data is above 70? So above 70 would be from here forward. So from here forward, how many spaces do you have? Only one space. So that's 25%. On the second question, it says, what percentage of the data was below 70? So below 70 would be 1, 2, 3 spaces. Each space is 25%. So that would be 75%. This is also common sense because if 25% of the data is above 70, then the rest of it is below 70, and the rest would be 75%. Now, number 3 says, what percentage of the data is above 20? So above 20 would be from this spot forward. From the lowest number forward, It has to be all of the information because 20 is the lowest number. So above 20 would be 100% of the information. Now, number 4 says, what percentage of the data is between 30 and 100? So between 30 and 100, how many spaces do we have? We have one, two, three spaces. Each space is 25%. So between 30 and 100, it's 75% of the data. Now, pay very close attention to number 5 because number 5 doesn't say numbers. So they require you to remember the definitions I gave you. So what percentage is contained within the quartiles? Quartiles are what make up the box in your box and whisker plot, the box. And the box is always two spaces. So whenever they ask you for how much information is contained within or outside of the quartiles, the answer is always going to be 50%. Now, before I move to the next page, the final page, I want to put two words up here that you need to know. Above 70, right? Sometimes they'll word it differently. They'll say at least 70. So make sure you know that at least means greater than or equal to. The reverse of that is at most. At most would be less than or equal to. So make sure you know the difference between those two because your answer is going to be opposite. The only time you'll get the answer right if you mix that up is if your answer is 50% because the opposite side of 50% is 50%. So every other answer you would have gotten wrong if you make a mistake on these words. At least, at most. I know it's common sense, but it's easy to make a mistake on them. And now the final page, the easy page. If you know how to create a box and whisker plot using this information like we did, then you can definitely answer questions about it. Now, this is a little more common sense, so please pay attention. The median is the middle line of the box. Middle line of the box is right here. Now, if you notice, it's right in the center between 43 and 46. So right the center would be 44.5. The lower quartile is the first line of the box. And again, it's in the center between two numbers. What number is right in between 41 and 43? 42. Next question is the upper quartile. That one, there's no need to write a number that's not visible because that one touches 46 exactly. So the upper quartile is 46. Only thing missing is your minimum and maximum, which are your two whiskers, your lowest and biggest point. So your lowest point here is 41, and your biggest point is 48. Now, some people looked at this 38 and said, no, the information goes all the way to 38. No, because this is just a number line. The information is the box plot itself, the blue. So let me now review the second one, just to give you another refresher. To find the median, it's the middle line of the box. Middle line of the box is right here. It touches 49. Lower quartile is the first line of the box. That touches an exact number, 46. Upper quartile is the right side of the box. Now that touches in between two numbers. Now if it was right in the center between 51 and 54, then the answer would have been 52.5. But it's not right in the center. So if it's closer to 51, we know the answer is 52. If it would have been closer to 54, then we know it would have been 53. Now the minimum and maximum are the only things left. Again, the minimum is right here, but it's not touching a number. So of the three numbers in between this, 44 and 45, since it's veering to the left, we know the answer is 44. Now the last value is the maximum. Maximum is just the highest point, and that one touches exactly 54. Any questions so far? Now let me show you the worksheets so you understand what I want and what I expect from you. Now over here, all you're doing is filling in the blank spaces with the words that I put in the word bank. Now notice how the word mean shows up twice, the word median shows up twice, and the word mode shows up twice. That is because it is two answers. So make sure mean shows up twice, median shows up twice, and mode shows up twice. Everything else is only going to be one question, one answer. So this is all stuff we talked about yesterday and today, most of it today. So for example, number 16, the blank is the best measure of center to use when there are extreme values. We talked about that. Median is the right one to use when there are extreme values. So number 16 would be median. So on and so forth. This is just definitions and information that I gave you during these last two lessons. Now the other activity, because it's two activities, this is a vocabulary one, is the box plot activity. This is simple because all you're going to do is answer questions about the graph that's already there for you. So here, for example, identify the minimum and maximum value. The minimum is this dot right here, which is 2. The maximum is 9. So your answer for that one would be 2 and 9. Look at number 2. Identify the lower quartile, the median, and the upper quartile. Like I said, quartiles deal with the box. So they're asking for the three values in the box. 4, 6, and 8. Now the only questions that are different than these, where you're going to have to do some more work, is the last two questions. On the last two questions, I just want you to create a box and whisker plot with these two situations. Just like we did on the bell ringer, so you can follow the steps and do it with this information. Both of these are lowered from least to greatest, so you don't have to lower from least to greatest. You can already start making your box and whisker plot. Any questions? Just unmute yourself and ask. I'll be right here. And I'm going to post this video on YouTube and Google Classroom now for you after I put your worksheets, your activities in. I'll let you know when to refresh.